Hello, in this lecture we will find out the values of line segments X and Y. In the drawing we have square DEBF that is inside the right triangle, triangle ABC. We know that one side of square DEBF is equal to 1 unit. That is to say, DB equals to BF equals to EF equals to ED equals to 1 unit. So I'll write it down that EF also equals to 1 unit and DE equals to 1 unit. And we also know that the hypotenuse of the right triangle ABC equals to 3 units. And we want to find out the values of line segments FC that equals to X and line segment AD that equals to Y. Okay, so first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. Okay, so I'll write it down. Side DE is parallel to side BF in square DEBF according to the rule that the opposite sides of a square are parallel to each other. BC is one side of triangle ABC, therefore it is absolutely a straight line. I'll write it down. Side BC is a straight line. And BF is part of the straight line BC, and we know that BF is parallel to DE, so we know that part of the straight line BC is parallel to DE, therefore we will conclude that BC also parallel to DE. BC also parallel to DE. Why? Because if we know that part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Okay, therefore BC is parallel to DE, and we have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So I repeat on rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So in our drawing, those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. Therefore, according to rule number 1, they are equal to each other. So we can write down that angle AED is equal to this angle that is actually angle ECB. And they are equal to each other according to rule number 1, because of the fact that those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. We proved that DE is parallel to BC, and those two angles are defined as corresponding angles that are located between parallel lines. Therefore, they are equal to each other according to rule number 1. So, if we define angle AED as theta, angle AED equals to theta, according to our definition, then from this equation, we will derive that angle ECB also equals to theta. Okay? And we also have another rule, rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. So I'll read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. In our drawing, AB is one side of the right triangle ABC. Therefore, AB, it is absolutely a straight line. AB is one side of the right triangle. It must be a straight line, so I'll write it down that side AB is a straight line. And if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. If we define angle ADE as X, then the sum of the angles on this side of the straight line AB at point D must be equal to 180 degrees. So which angles we have here? We have 90 degrees plus angle X according to rule number 2, the sum of those two angles must be equal to 180 degrees. According to rule number 2, so 90 degrees plus X equals to 180 degrees. We will subtract 90 degrees from this equation, and we will get that angle X equals to 100 degrees, 180 degrees minus 90 degrees is equal to 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we substitute angle X by right angle. So actually, if angle ADE is a right angle, then triangle ADE is a right triangle. Likewise, BC is one side of the right triangle ABC. Therefore, it is absolutely a straight line. I'll write it down that BC is a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees according to rule number 2. So if we define angle EFC, this angle is angle Y, then at point F at the upper side of the straight line BC, we have here 90 degrees plus angle Y. The sum of those two angles must be equal to 180 degrees according to rule number 2. Angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation, and we'll get that angle y equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle y is a right angle, that is to say it equals to 90 degrees. So we substitute angle y by a right angle. And again, because of the fact that angle EFC is a right angle, therefore triangle EFC is a right triangle. So we found out that triangle ADE is a right triangle, triangle EFC is a right triangle, and the fact that triangle ABC is a right triangle is given us in the question. Okay, so here we will focus on the right triangle, triangle ADE, on the right triangle, triangle ADE. Tangents alpha and tangents theta. This is tangents theta, so tangents theta equals to AD over DE. I will repeat again. In the right triangle, triangle ADE, tangents theta equals to AD over DE. But AD equals to y, it is given us in the question. And DE equals to 1 because it is one side of square DEBF. So in conclusion, we actually found out that tangents theta equals to y. So according to equation number 1, tangents theta equals to y. In the next step, we will focus on the right triangle, triangle EFC. On the right triangle, triangle EFC. This right triangle. We know that tangents theta equals to EF over FC. I'll repeat again. According to equation number 2, in the right triangle, triangle EFC, tangents theta equals to EF over FC. That is to say, tangents theta, and we know that EF equals to 1, and FC equals to X, it is given us in the question. So in conclusion, we got that according to equation number 2, tangents theta equals to 1 over X. I repeat again. According to equation number 2, in the right triangle, triangle EFC tangent theta equals to 1 over x. So we have two different expressions for tangent theta. Therefore, we'll create equation number 3 that states that tangent theta according to equation number 1 equals to tangent theta according to equation number 2. So tangent theta according to equation number 1 equals to y, and it must be equal to tangent theta according to equation number 2, that is actually equals to 1 over x. So we actually found out that y equals to 1 over x. What does this equation number 3 means? It means that the number y is the inverse number of x. And we can also say that the number x is the inverse number of y, because if we multiply equation number 3 by x and then we will divide it by y, we will get that x equals to 1 over y. So in conclusion, we can say that x is the inverse number of y and y is the inverse number of x. Whenever you multiply two numbers by each other and you get 1, it means that the two numbers are inverse numbers to each other. Okay? Here, if we multiply equation number 3 by x, we will get that x times y equals to 1. Okay, so I will write the conclusion from equation number 3 here, that y is the inverse number of x, and x is the inverse number of y. X is the inverse number of y. It means that if, for example, y equals to 5, then x must be equal to 1 over 5. Or if x equals to 4, then y must be equal to 1 over 4. Okay? In the next step, we will focus on the right triangle ABC. In the right triangle ABC, according to the Pythagoras theorem, here the letters P, T is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in the right triangle ABC, it means that the hypotenuse is AC and the square of the hypotenuse is AC squared. And it equals to the sum of the squares of the perpendiculars, that is to say, it equals to AB squared plus BC squared. I repeat again, in the right triangle ABC, according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, we will get that AC squared is the square of the hypotenuse, and it equals to the sum of the squares of the perpendiculars, that is to say, it equals to AB squared plus BC squared, according to equation number 4. So we know that AC equals to 3, therefore AC squared is 3 squared, 3 squared is 9, and it equals to AB squared. AB equals to y plus 1, therefore AB squared will be equal to y plus 1 squared plus BC squared. BC equals to x plus 1, so BC squared will be equal to x plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4, and we will get that y plus 1 squared is y squared plus 2y plus 1 plus x plus 1 squared is x squared plus 2x plus 1, and it equals to 9. One plus 1 is 2, so I will write it down. According to equation number 4, we get that y squared plus 2y plus 2 plus x squared plus 2x equals to 9. According to equation number 3, y equals to 1 over x. I write it down. Y equals to 1 over x. So we substitute y by 1 over x. And we get that according to equation number 4, y squared will be equal to 1 over x squared plus 2y is 2 times 1 over x plus 2 plus x squared plus 2x, and we will subtract 9 from this equation. minus 9 equals to 0. Here we will organize the expressions and we'll get that x squared plus 1 over x squared plus 2 plus 2x plus 2 over x minus 9 equals to 0. Here x squared plus 1 over x squared plus 2 equals to x plus 1 over x squared. So I write it down, equals to x plus 1 over x squared. And here we will take a common factor of 2 out of those two expressions, and we will get that 2 is a common factor, so here what is left from 2x is x, and what is left from 2 over x after we took from it as a common factor 2, what is left is 1 over x minus 9 equals to 0. Here we will define t as x plus 1 over x, that is to say t equals to x plus 1 over x according to our definition, and we'll substitute x plus 1 over x by t because they are equal to each other according to our definition, and we will get that here t squared plus here is 2t, here minus 9 equals to 0. So here we have a quadratic equation. The variable in this quadratic equation is t, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to a special formula for x. X actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a, and in our specific quadratic equation the variable that we are looking for is t. So actually x equals to t, and the coefficients are as follows: a equals to 1, b equals to 2, and c equals to minus 9. So here we will put the data inside the equation for x in order to find out the value of x that in our case x equals to t. The variable that we are looking for is t. So x equals to t, so we get that t equals to minus b, b is 2, so minus b is minus 2, plus minus square root of b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a, minus 4 times a is 1, so minus 4 times 1 is minus 4, and minus 4 times minus 9 is plus 36 over 2 times a. 2 times a is 1, so 2 times 1 is 2. So in conclusion, we found out that t equals to minus 2 plus minus, again, minus 4 times minus 9 is 36, and 36 plus 4 is 40 over 2. So we get that t equals to minus 2 plus minus 40 equals to 4 times 10, and the square root of 4 is 2, so here we'll get 2 times square root of 10 over 2. So here we have two solutions that are possible for t. The first solution is that t equals to minus 2 plus 2 times square root of 10 over 2. And the second solution that is possible for t is that t equals to minus 2 minus 2 times square root of 10 over 2. Here minus 2 over 2 is minus 1. So here we get minus 1 minus square root of 10 . But according to our definition, t equals to x plus 1 over x, that equals to minus 1 minus square root of 10 . What is x? X is length. X is length, therefore it must be a positive number. Therefore x plus 1 over x is a positive number, while minus 1 minus square root of 10 is a negative number. And a positive number can never be equal to a negative number. Therefore, this possibility is not correct. So we'll cancel this possibility. And we're left only with the possibility that the value of x is minus 2 plus 2 times square root of 10 over 2. So t equals to minus 2 over 2 is minus 1, plus 2 over 2 is 1, so plus square root of 10 again t equals to square root of 10 plus 1, and according to our definition t equals to x plus 1 over x, that equals to square root of 10 plus 1. It is actually minus 1, square root of 10 minus 1. So here we will multiply x by x and then we will divide it by x in order to have a common factor with this number expression, and we'll get that x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. So here we subtract square root of 10 minus 1 times x from this equation, and we will get here a quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So here we got a quadratic equation. In this quadratic equation, we know that a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we get here that x equals to b is square root of 10 minus 1, so minus b, minus and minus is plus, so we get here square root of 10 minus 1 plus minus square root of b squared. B squared will be equal to square root of 10 minus 1 squared minus 4 times ac. A is 1, c is 1, so here we have minus 4 over 2 times a. A is 1, so 2 times 1 is 2. So in conclusion, we got that according to this equation, we will get that x equals to square root of 10 minus 1 plus minus, here we have square root of 10 minus 1 squared, that is actually square root of 10 squared, that is 10, plus 1 minus 2 times square root of 10 times 1 minus 4 over 2. So we actually found out that x equals to square root of 10 minus 1 plus minus square root of 10 plus 1 is 11, 11 minus 4 is 7, so it is 7 minus 2 times square root of 10 over 2. What is the value of 7 minus 2 times square root of 10? The value of 7 minus 2 times square root of 10, it is actually equal first of all, 7 is 5 plus 2, 7 equals to 5 plus 2, and square root of 10 is square root of 2 times square root of 5, so I'll write it down. And we know that 5 is square root of 5 squared, and 2 is square root of 2 squared, minus 2 times square root of 5 times square root of 2. Actually, this expression, square root of 5 plus square root of 2 minus 2 times square root of 5 times square root of 2 is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. And here a equals to square root of 5 and b equals to square root of 2. So we will get that this expression equals to a minus b squared. That is to say, it equals to square root of 5 minus square root of 2 squared. So we will substitute 7 minus 2 times square root of 10 inside the root by square root of 5 minus square root of 2 squared, because of the fact they are equal to each other, so we can substitute between them, and we will get that x equals to square root of 10 minus 1 plus minus, I repeat again, we will substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 squared, because of the fact they are equal to each other, so we can substitute between them, and we get here square root of 5 minus square root of 2 squared over 2. So here we have x equals to square root of 10 minus 1 plus minus. Here we have square and root, and the square cancels the root, And we left only with square root of 5 minus square root of 2 divided by 2. So here we have two solutions that it's possible for x. We will define the first solution as x1 and the second solution as x2. So the first solution, that will be x1, will be equal to square root of 10 minus 1 plus square root of 5 minus 2 over 2. And the second solution for x will be x2, and x2 will be equal to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. So we'll continue with this solution x1, and we will get that x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. Here we will substitute square root of 10 by square root of 2 times square root of 5, and we will get that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. So here we will take square root of 5 as a common factor, and we will get that x1 equals to square root of 5 was taken as a common factor, and inside the brackets we will have square root of 2 plus 1 and here we will take minus 1 as a common factor, and inside the brackets we will have 1 plus square root of 2, all divided by 2. Here we will take square root of 2 plus 1 as a common factor, and we will get that x1 equals to square root of 2 plus 1 was taken as a common factor, and inside the brackets we will have here square root of 5, and from this expression we will have minus 1, all divided by 2. So we actually found out that x1, the first solution for the quadratic equation, equals to square root of 2 plus 1 times square root of 5 minus 1, all divided by 2. We repeat on the same process for x2, and we get that x2 equals to square root of 10 minus 1 minus square root of 5, minus and minus is plus, so it will be plus square root of 2 over 2. So x2 Here we will substitute square root of 10 by square root of 2 times square root of 5, and we will get that square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. So here we'll take square root of 5 as a common factor, and we'll get that x2 equals to, so square root of 5 is taken as a common factor. Inside the brackets we will have here square root of 2 minus 1 plus square root of 2 minus 1. So here we will take all divided by 2, of course. Here we will take square root of 2 minus 1 as a common factor, and we will get that x2 equals to square root of 2 minus 1 was taken as a common factor. And what is left from this expression after we took from it square root of 2 minus 1? Here what is left is square root of 5. And here what is left, it is actually 1. All divided by 2. So we have two solutions that are possible, x1 and x2. Now we will multiply the two solutions the quadratic equation by each other, and we will get that x2 times x1, or x1 times x2, x1 times x2 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is actually x1, and we will multiply it by x2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. Okay? We can organize the expressions in another way. x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1, all divided by 2 plus 2. So we organized the expressions in a different way. We have here square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1. Actually, square root of 2 plus 1 times square root of 2 minus 1 is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared, and the expression square root of 5 plus 1 times square root of 5 minus 1 is also very similar to this algebraic identity. So we will use this algebraic identity in order to find out the values of those two expressions. Here square root of 2 is a, a equals to square root of 2, and the square root of 2 squared is 2, minus b squared. b equals to 1. b squared is 1 square, 1 square is 1, so it is minus b squared minus 1. And we also have those two expressions. Here, a plus b times a minus b, a is equal to square root of 5, and the multiplication is equal to, according to this algebraic identity, to a squared. A equals to square root of 5 for a squared, so a squared will be equal to square root of 5 squared. Square root of 5 squared is 5, minus b squared. b is 1, so b squared is 1 squared, 1 squared is 1, so it is minus 1 over 2 times 2 is 4. Okay, so 2 minus 1 is 1, 5 minus 1 is 4, all divided by 4. 1 times 4 is 4, over 4 is 1. So we found out that x1 times x2 equals to 1. Therefore, we can write down that x1 is the inverse number of x2, and the opposite is also true. x2 is the inverse number of x1. Okay? But according to equation number 3, we found out that x times y equals to 1. And because of the fact that x times y equals to 1, we can also write down that x is the inverse number of y, and also y is the inverse number of x. Okay? So the solution, the values of x and y will be as follows. We will have x1 and y1. x1, we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is x1, and we know that y1 must be the inverse number of x1. Okay? But we have already found out that x2 is the inverse number of x1. Therefore, y1 will be equal to x2. Okay? We have x1 that is actually square root of 2 plus 1 times square root of 5 minus 1 over 2. And here y1 must be the inverse number of x1. Which number is the inverse number of x1? It is actually x2. x2 is the inverse number of x1. Therefore, y1, that is also the inverse number of x1, will be equal to x2. That is to say, x2 is square root of 2 minus 1 times square root of 5 plus 1 over 2. This will be y1 and the second solution for the problem will be x2 and y2, x2 and y2. Here we have already found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And we know that x2 and y2 are two inverse numbers. x2 is the inverse number of y2. So which number is the inverse number of x2? We have already found out that x1 is the inverse number of x2. And we are looking for the inverse number of x2. And we have already found out that x1 is the inverse number of x2. Therefore, x1 will be the inverse number of x2. That is to say, y2 will be equal to x1. y2 will be equal to x1. That is to say, the value of y2 will be equal to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay? Again, I repeat again on what we did here. We have already found out that x1 is the opposite number of x2, and x2 is the opposite number of x1. And according to equation number 3, x times y equals to 1. That is to say, x and y are two inverse numbers. X is the inverse number of y and y is the inverse number of x. So the solution x1, y1 is such solution that according to equation number 1, they are two inverse numbers to each other. x1 is the inverse number of y1 according to equation number 3, and y1 is the inverse number of x1. So we have already found out that x1 is the inverse number of x2, and we want that y1 will be the inverse number of x1. So we will choose x2 that will be equal to y1 because of the fact that x2 is the inverse number of x1, and also we have here the second solution x2, y2, and we know that x2, we actually know that x2 times y2 must be equal to 1 according to equation number 3. And according to equation number 3 also, x1 times x1 times y1 must be equal to 1. Okay? And because of the fact that we have already found out that x1 is the inverse number of x2, so in the first solution, when we have x1, we know that the inverse number of x1 is x2, therefore y1 will be equal to x2 because of the fact that x1 and y1 are also inverse numbers to each other. Therefore y1 will be equal to x2, and here we have x2 times y2 must be equal to 1, that is to say x2 is the inverse number of y2 and y2 is the inverse number of x2, and we already found out that x1 is the inverse number of x2, therefore y2 will be equal to x1. y2 will be equal to x1, and here x1, y1, we know that x1 times y1 equals to 1, that is to say those two numbers are inverse numbers to each other, so x2 is the inverse number of x1, therefore x2 will be equal to y1. And here we also know that x2 times y2 equals to 1, that is to say x2 and y2 are two inverse numbers to each other. So, and we know that x1 is the inverse number of x2, therefore x1 will be equal to y2. Okay, so that is the solution to the question. Now I'll summarize the lecture. We have here square DEBF. You know that one side of this square is equal to 1 unit. This square is inside a right triangle, the right triangle ABC. You know that the hypotenuse of the right triangle ABC AC equals to 3 units. And we want to find out the values of line segment FC that is X and the value of line segment AD that is Y. And first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. DE is parallel to BF. But we also know that BC is one side of the right triangle ABC, therefore it is absolutely a straight line. And BF is part of BC. BF is part of BC and is parallel to DE. So if part of BC is parallel to DE, then BC itself must be also parallel to DE. Therefore, we'll conclude that BC also parallel to DE. Then I presented to you rule number 1, that corresponding angles between parallel lines are equal to each other. And those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, that is to say DE is parallel to BC, therefore they are equal to each other according to rule number 1. That is to say, angle AED equals to angle ECB according to rule number 1. And if we define angle AED as theta, then according to this equation, we get that angle BCE also equals to theta. This angle also equals to theta. Or it is actually angle ECB that also equals to theta. So those two angles are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Here we have AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. And if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees plus the missing angle that we defined as angle X must be equal to 180 degrees. Here, 90 degrees plus this angle, that is angle X, according to our definition, must be equal to 180 degrees. According to rule number 2, we subtracted 90 degrees from this equation and we found out that angle X equals to 90 degrees. So this angle is a right angle, therefore triangle ADE is a right triangle. Likewise, we know that BC is one side of the right triangle, triangle ABC, therefore it must be a straight line. So we can write down that BC is a straight line, and according to rule number 2, if we focus on the upper side of the straight line BC at point F, the sum of the angles must be equal to 180 degrees. So if we define this angle as Y plus this angle that is equal to 90 degrees, the sum of those two angles must be equal to 180 degrees. 90 degrees here, 90 degrees plus angle Y must be equal to 180 degrees according to rule number 2. That the sum of the angles on one side of a straight line is equal to 180 degrees. We subtracted 90 degrees from this equation and we got that angle Y equals to 90 degrees. So this angle Y equals to 90 degrees, therefore triangle EFC is a right triangle. Then we focus on this right triangle, triangle ADE. Here we know that tangent theta equals to AD over DE. In the right triangle, triangle ADE, according to equation number 1, tangent theta equals to AD over DE. And AD equals to Y, DE equals to 1. AD equals to Y, DE equals to 1. So in conclusion, we found out that tangent theta equals to Y according to equation number 1. Then we focused on the right triangle, triangle EFC. On the right triangle, triangle EFC, tangent theta equals to EF over FC. In the right triangle, triangle EFC, tangent theta equals to EF over FC. But EF equals to 1, FC equals to X according to what is given us in the question. So in conclusion, we found out that according to equation number 2, tangent theta equals to 1 over X. So we know that tangent theta according to equation number 1, that is equal to Y, must be equal to tangent theta according to equation number 2, that equals to 1 over X. So equation number 3 states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2, that is to say Y equals to 1 over X. Then we multiplied equation number 3 by X and we got that X times Y equals to 1. What does equation number 3 means? It means that Y is the inverse number of X and X is the inverse number of Y. That is to say, if X equals to 4, then Y must be equal to 1 over 4. Okay? Then we focused on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, according to equation number 4, the square of the hypotenuse is AC squared and it must be equal to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BC squared. And AC equals to 3, so AC squared is 3 squared. 3 squared is 9. AB equals to Y plus 1, so AB squared equals to Y plus 1 squared. BC equals to X plus 1, so BC squared is X plus 1 squared. So in conclusion, we got that according to equation number 4, 9 equals to 1 plus 1 square plus x plus 1 square. Here we open the brackets on this side of equation number 4, and we got that y plus 1 square equals to y square plus 2y plus 1, and x plus 1 square equals to x square plus 2x plus 1, that equals to 9. Here we organize the numbers here, and we got that we organize the expressions, and we got that in equation number 4, we got that y square plus 2y plus 2 plus x square plus 2x equals to 9. But according to equation number 3, y equals to 1 over x. So we can substitute y by 1 over x in equation number 4. We did it, and we got that y square is 1 over x square plus 2y is plus 2 1 over x. It is 2 over x plus 2 plus x square plus 2x minus 9 equals to 0. Here we have x squared plus 1 over x squared plus 2, it is 1 unit, plus 2x plus 2 over x minus 9 equals to 0. The expression inside the brackets is equal to x plus 1 over x squared. And here we took 2 as a common factor out of these two expressions. And inside the brackets we got x plus 1 over x minus 9 equals to 0. Here we defined t as x plus 1 over x, that is to say t equals to x plus 1 over x, according to our definition. So we substituted x plus 1 over x in equation number 4 by t, and we got that t squared plus 2t minus 9 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. The special formula is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific expression, in our specific quadratic equation, we know that the variable that we are looking for is t, a equals to 1, b equals to 2, and c equals to minus 9. So the only thing that is left to do is to put the data inside the equation for x and to find out the value of t, because x equals to t. So here we will get that t equals to b is 2, and minus b will be equal to minus 2 plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, it is actually minus 4 times minus 9 over 2, because 2a is 2 times 1, that is 2. So we got that t equals to minus 2 plus minus 4 plus 36 is 40 over 2. So t equals to 2 plus minus 40 equals to 4 times 10, and the square root of 4 is 2. So in conclusion, we got that t equals to minus 2 plus minus 2 times square root of 10 over 2. And we have here two solutions that are possible for t. The first solution is that t equals to minus 2 plus square root of 2 times the square root of 10 over 2. And the second solution is t equals to minus 2 times square root of 10 over 2. But we know that t is equals to x plus 1 over x, and x is length. S is length, therefore it must be a positive number. So on this side of the equation we have a positive number. On the other side of the equation, minus 1 minus square root of 10 is a negative number. and a positive number can never be equal to a negative number. Therefore, we have a contradiction. That is to say, this solution is not possible. We cancel this solution and we left with the only solution that t equals to minus 2 plus 2 times square root of 10 over 2. Here, minus 2 over 2 is minus 1. 2 over 2 is 1. So in conclusion, we found out that t equals to minus 1 plus square root of 10. Or t equals to square root of 10 minus 1, and t, according to our definition, equals to x plus 1 over x. That equals to square root of 10 minus 1. We multiplied x by x and then we divided by x in order to overcome the factor with 1 over x, and we got that x squared plus 1 over x equals to square root of 10 minus 1. We multiplied this equation by x and we got that x squared plus 1 equals to square root of 10 minus 1 times x. And here we subtracted square root of 10 minus 1x from this equation, and we got here a quadratic equation, x squared minus square root of 10 minus 1 times x plus 1 equals to 0. In this quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1, and the solution of the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x equals to minus b. Here minus and minus is plus, so we left only with square root of 10 minus 1 plus minus square root of b squared is actually square root of 10 minus 1 squared over 4 times AC. Over 4 times AC is minus 4 because A equals to C equals to 1, all divided by 2. So here we got that x equals to square root of 10 minus 1 plus minus square root of 10 minus 1 square equals to 10 plus 1 minus 2 times square root of 10, and we also have to subtract minus 4, all divided by 2. 10 plus 1 is 11, 11 minus 4 is 7, so it is actually 7 minus 2 times square root of 10 over 2. And what is the value of this expression that is inside the root? The value of 7 minus 2 times square root of 10, it is actually 5 plus 2. 5 plus 2 equals to 7, so we substituted 7 by 5 plus 2, and then we substituted square root of 10 by square root of 2 times square root of 5, so in conclusion we will have 5 plus 2 minus 2 times square root of 2 times square root of 5, and we know that 5 is square root of 5 square and 2 is square root of 2 square, so in conclusion we found out that 7 minus 2 times square root of 10 is square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2, and this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. Therefore, according to the algebraic identity that I stated, we can substitute this expression by a minus b squared when a equals to square root of 5, b equals to square root of 2, so a minus b squared will be equals to square root of 5 minus square root of 2 squared. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 squared. So we can substitute 7 minus 2 times square root of 10 that is inside this root by square root of 5 by square root of 2 squared. So we did it and we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 square over 2. And here we have the square cancels the root and we left only with square root of 5 minus square root of 2. So in conclusion, we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus 2 over 2. So here we have two solutions that are possible. The first solution is x1, that equals to square root of 10 minus 1 plus square root of 5 minus 2 over 2. So x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. Here we substituted square root of 2 by square root of 5 times square root of 2, and we found out that x1 is equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus 2 over 2. Here we took square root of 5 as a common factor, and inside the brackets we will have square root of 2 plus 1 minus 1 plus square root of 2. Here we took minus 1 as a common factor, and inside the brackets we have square root of 2 plus 1. Then we took square root of 2 plus 1 out of these expressions, and inside the brackets we left with square root of 5 minus 1. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We did the same process for the second solution, that is x2. x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. Here we open the brackets and we got that x2 equals to square root of 10 minus 1. And here, after we open the brackets, we will have here minus square root of 5, and minus is plus. So we got here plus square root of 2 over 2. And here we substituted square root of 5 by square root of 2 times square root of 10. And we got that x2 equals to square root of 5 times square root of 10 minus 1 minus square root of 5 by square root of 2 over 2. Then we took square root of 5 out of these expressions as a common factor, so square root of 5 is a common factor, and inside the brackets what is left is square root of 2 minus 1 plus square root of 2 minus 1. Then we took square root of 2 minus 1 out of these expressions, and inside the brackets we left with square root of 5 plus 1. So in conclusion, we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So we got two possible solutions for the quadratic equation, x1 and x2. Then we multiplied x1 by x2, and we got that x2 times x1 equals to 1. If x2 times x1, x1 is this expression, x2 is this expression, and x2 times x1 is equal to this expression. Actually we have square root of 2 plus 1 times square root of 2 minus 1, and we have square root of 5 plus 1 times square root of 5 minus 1, all divided by 2 times 2. And according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared, we will get here that square root of 2 is a and b is 1. So square root of 2 square is 2, and square root of 1 square is 1 square, 1 square is 1, so it is a square minus b square, that is to say it is 2 minus 1, 2 minus 1 is 1. And then we multiplied those two expressions. Here a equals to square root of 5 and b equals to 1. Square root of 5 square is 5, and square root of 1 square is 1, so 5 minus 1 is 4. So we have 1 times 4 over 4, 1 times 4 is 4, and 4 over 4 is 1. So if we found out that x1 times x2 equals to 1, that is to say x1 is the inverse number of x2, and x2 is the inverse number of x1. But according to equation number 3, we have already found out that x times y equals to 1. It means that x is the inverse number of y, and y is the inverse number of x. Therefore, we have x1 equals to this expression. So y1 must be equal to the inverse number of x1. but we have already found out that x2 is the inverse number of x1. That is to say, y1 will be equal to x2. So we have here x2, because x2 equals to y1, and when we multiply x2 by y1, we will get 1. Then we have here x2, this is the expression for x2, and because of the fact that we know that x2 times y2 must be equal to 1 according to equation number 3, it means that y2 must be the inverse number of x2. Which number is the inverse number of x2? We have already found out that x1 is the inverse number of x2. Therefore, y2 will be equal to x1. So this expression is x1. Okay? So this is the solution of our problem. Here, if you multiply x1 by 1, you will get 1. Exactly according to what equation number 3 demands. And if you multiply x2 by y2, you will get 1, exactly according to what equation number 3 demands. Okay, so those are the two solutions of the problem. x1, y1 is the first solution, x2, y2 is the second solution. Okay, thank you very much.